All right, today guys we're going to continue our learning in trigonometry, and we got to start off with quite a bit of vocabulary to make sure we're all on the same page. Some of this should be quite obvious to you, but I don't want to assume that we know any of this, so we're going to go over it step by step. First of all, we need to talk about what an angle is. An angle is the union of two rays with a common vertex. All right, so for instance, let's say we have this angle, and I will draw the angle in blue. This is the x and y axis, and this is the angle. All right, so that is called a ray, and that is another ray, and this right here is called the vertex. All right, so once again, this is just a little bit of vocab. Okay, that is the vertex. All right, now this first ray right there, that is called, we'll call that the initial side. We'll call that the initial side. And we will call this other ray right here, we'll call this one the terminal side. Terminal because that's where it terminates or it ends. So this is just a little vocab to start off. That is the terminal side of the angle. All right, and the most common position that we're going to be looking at right now is called standard position. Standard position is when the initial side is along the x-axis. All right, is when the initial side is along the x-axis. So you can see that right here. Standard position is with the vertex at the origin, and the initial side is lying along the positive x-axis. All right, so that's what we're going to be looking at here at the beginning of this unit. Now, we also want to understand what a positive angle is and what a negative angle is. All right, so a positive angle. Positive angle is an angle. So let's say this is one of our sides. An angle that is going clockwise, or counterclockwise, excuse me. So when you rotate counterclockwise, that is a positive angle. So let's say I want theta to be 30 degrees. I need to rotate 30 degrees counterclockwise, and that is the angle. All right, if I say I want theta to be negative 30 degrees, all right, then that means that we need to rotate backwards. All right, so that means we need to rotate clockwise 30 degrees. And so now the angle is going to be somewhere in the fourth quadrant. All right, so make sure you understand positive angles go counterclockwise and negative angles go clockwise. All right, let's talk about something called coterminal angles. Coterminal angles, all right? Coterminal angles are a very, very simple concept. Basically, what it's saying is, let's say I have an angle of 30 degrees. All right, so just like we talked about before, that is 30 degrees. All right, if I go around the circle from here, let's say I go around the circle all the way and I end up exactly where I started, how many degrees have I just rotated? If you go all the way around the circle, you have just rotated 360 degrees. So if I add 360 degrees to 30, I get 390 degrees. Okay? But I can also rotate backwards. So I'm going to draw that in red. I can also rotate backwards. Now once again, if I rotate backwards, then that is a negative angle, and I just talked about that in the previous slide. That's a negative angle, so that means I rotated negative 360 degrees. So what I need to do is I need to take 30 degrees and subtract 360 degrees, and I end up getting negative 330 degrees. And that is actually the answer to letter A. So let's review. How do you get coterminal angles? You add or subtract 360 degrees. Now, just so you know, you can add 360, then add 360 again, then add 360 again. So what did we just learn? That every angle has an infinite number of coterminal angles because, watch my pen, you can go around the circle, around the circle, around the circle, around the circle. You can keep going around the circle as many times as you want. And every time I go around, I just need to add 360 degrees. And so I would have added, I don't know, 10 times 360 right there, however many times I went around. So that's how you find coterminal angles. Very, very simple. Add 360, subtract 360. Now, what if the angle given to you is in radians? All right, well, let's remember from a couple units ago, the conversion. Pi radians is equal to 180 degrees. So what does that mean? That means that 2 pi radians is equal to 360 degrees. So take a wild guess. If the angle is in radians, how do you find coterminal angles? Well, you don't add or subtract 360, you add and subtract 2 pi. Why? Because 2 pi is the same as 360 in radians. Alright, so let's go ahead and do letter B real quick, and then we'll jump into letter C. Letter B, we have an angle, negative 150. We say, well, how do we get the coterminal angles? Alright, it says find one that is positive and one that is negative. Okay, so to find the positive one, we add 360. And we end up getting 210. And then, if we want to get a negative one, we would subtract 360. And that's going to give us negative 510. And those are the answers to letter B. All right, letter C. Letter C is the first one we're seeing here. That is in radians, 2 pi over 3. Now, I'm going to tell you right now, what a lot of students are going to do, and they're going to end up getting it wrong later on, is because they are not comfortable with adding and subtracting fractions, a lot of students are going to try to change every radian angle into a degree, and then that way they can add and subtract 360. I want to caution you, do not do that, do not do that, do not do that, all right? Learn to add the fractions. You'll see why later, all right? So we need to take 2 pi over 3, and we need to add 2 pi to that. We also need to take 2 pi over 3, and we need to subtract 2 pi from that. Now, once again, what do we have to do in order to add fractions? We have to get a common denominator. So that means we need to multiply by 3. We need to multiply by 3. We'll do the same thing here. Multiply by 3. Multiply by 3. So what is that going to give us? That's going to give us 2 pi plus 6 pi, which ends up being 8 pi over a common denominator of 3. Look how easy that is. No more fear of fractions. Just get a common denominator. You do not need to, once again, change this into an angle in degrees. That is not necessary. All right, so for the negative one, you get 2 pi minus 6 pi, which is going to end up being negative 4 pi over 3. And those are the answers. All right, example 2 can be a little bit confusing if we don't understand the wording. And so that's when the advantage of having a video, you can rewind it and listen to it as many times as you need so that you can understand what it's actually saying here. All right, let theta be the acute angle. There it is. So let's make sure you understand what it's saying. Let theta be the acute angle, which means what? An acute angle is an angle that is between 0 and 90, right? So That's what theta is. In standard position, what does that mean? If you go back to the first slide, standard position means that one side of the angle is on the x-axis and the other side is in some other quadrant, whose terminal side contains the point -5, 3. So let's see if we can draw this. Okay, so that's our basic xy coordinate. So here is one of the sides, and if the point -5, 3, so let's just count that off here. Let's see, 1, 2, 3, 4, 5, and 1, 2, 3. So that is the point right there. And so the other side of the angle is going to be there. All right, so theta, now what type of angle is the angle that I have in red? That is an obtuse angle, right? So that's not the angle that they're looking for. We are interested in this angle right here. We'll call that theta because that's the acute angle. All right, and so it says find the 6 trig functions of theta. All right, so we can label this triangle because we know that this side is 3 and this side is -5. Now let me caution you something very, very important, very important. Please make sure that anytime you are labeling a triangle with its sides that you include a negative if you go left or down. Let me repeat that. You need to include a negative if you're in a quadrant that's not quadrant 1. You need to include a negative if you go left or down. So you may want to write that in the notes. All right, that's very important. So we're going to do the Pythagorean Theorem to get the hypotenuse. So that's going to be 3 squared plus -5 squared equals c squared. So that's going to be 9 plus 25 equals c squared. So c is equal to the square root of 34. All right, so let's put that in there, square root of 34. All right, now that we've got all 3 sides, we're back to what we learned in part 4.2. We need to get all 6 trig functions. So let's start with what we remember. So, ka, toa. All right, so sine is opposite over hypotenuse. So we're going to go through these really quickly. Sine of theta is opposite over hypotenuse, which is going to be 3 over root 34. Right now I'm going to leave the radicals in there on the bottom. Cosine of theta is going to be the adjacent, so it's going to be -5 over root 34. And then tangent of theta is going to be opposite over adjacent, so -3 over 5. And now I'm going to say cosecant of theta. It's going to be the flip of the sign, so that's going to be root 34 over 3. And secant of theta is going to be root 34 over -5, but I'm just going to put the negative on top. And then cotangent of theta is going to be -5/3. All right, and those are the 6 trig functions of angle theta. All right, it says that we need to find the 6 trig functions of 315 degrees. All right, so this requires us to know what quadrants and what angles are in which quadrants. So, 0 to 90 is in quadrant 1. 90 to 180 is here. 180 to 270 is here. And 270 to 360 is in the 4th quadrant. All right, we'll talk about this later when we do the unit circle, but those are the 4 quadrants. So 315 is going to be somewhere in the 4th quadrant. So let's see if we can draw that. All right, 315. So that is going to be right there. Okay, so here we have this triangle, and anytime we ask you to find the six trig functions of a specified angle, it's going to always relate back to the 30, 60, 90 triangle or the 45, 45, 90 triangle. Make sure you understand that. That is extremely important right here. Knowing those two triangles. So, which of the two triangles that I just mentioned would be the one that we would want to use, assuming that, watch this angle is 315. Well, if all the way around the circle is 360, and we've gone around 315, what angle is left? Well, that's pretty simple. That's going to be 45 degrees. So that's going to make that 90, and that's going to make that 45 also. All right, so we have a 45, 45, 90 triangle. From the previous video, we remember that the sides are going to be 1, 1, and root 2. However, what did I just say about 5 minutes ago? Anytime you're going left or down, you need to make the side negative. This is where students will lose points on quizzes and exams by not making the sides negative. So from here you can find the six trig functions of 315. Once again, we're going to do sine of 315. Now we're going to use the 45-degree angle right here to get all of these trig functions. So opposite over hypotenuse, which is going to be -1 over root 2, and then we might as well go ahead and get the cosecant, which is the flip of that, so that's going to be -root 2. And then we have the cosine, and that's going to be adjacent, so it's going to be adjacent over hypotenuse, 1 over root 2, and the secant is just going to be root 2. And then we have the tangent of 315, and that's just going to be -1 because it's going to be opposite over adjacent. And then the cotangent is going to be the flip of that, and these should all be 315 and 315 and 315. And that's going to be -1 as well. Now, make sure you understand that normally we write this as -root 2 over 2, and that occurs when you get the root off of the bottom. And, whoa, that should have been a root 2 right there. So this one is going to end up being root 2 over 2 as well. All right, those are the six trig functions of 315. All right, we're going to go through these relatively quickly here. Find the following without a calculator. All right, so letter A. It says find the sine of -210 degrees. Now the first thing that jumps out at me there is that the angle is negative. And we don't like to deal with negative angles, and so therefore we're going to make that into a positive angle because we learned a few moments ago that every angle has coterminal angles. So we're going to take -210 and we're going to add 360 to that. When you add 360 to -210, you end up getting 150. So hey, what is this problem really asking us to do? It's asking us to find the sine of 150 degrees, which we can do. So we're going to make a triangle, and 150 is in the second quadrant, so we're going to make a triangle in the second quadrant. Now pay very close attention to this. If we rotated, let's just see if this makes sense to you. If we rotate 150 degrees counterclockwise, what angle is left right there? Well, it has to be 30, right? Because 180 degrees is rotating all the way to the x-axis, all right? So that has to be 30 degrees. That's the key. So that's going to tell you that this triangle is a 30, 60, 90 triangle. Okay, now across from 30 is what? 1. Across from 60 is root 3, but we went left, so we have to make it negative. And across from the 90 is always 2. So now that you've got the three sides, it's simple. Sine is what? Opposite over hypotenuse. Opposite. And you're always, by the way, you're always going to be using the angle that is at the origin, not the 60, not the one up there. Always the one at the origin, so don't use that one. All right, and so what do we have? Opposite over hypotenuse. That's going to be 1/2. You're done with that problem. All right. Example 2, or letter B rather. Tangent of 5 pi over 3. All right, now let's just kind of see what that is. 5 pi over 3, it's going to be a little tricky for you for a little while. So 5 pi over 3. How about we convert that to an angle in degrees? So what did we say before? Pi is 180. So this is the easiest way to do this. 5 times 180 over 3. All right, and 180 over 3 is 60, right? 60 times 5, so 5 times 60 is 300. All right, so that means we need to be in the 4th quadrant. So we need to make a triangle in the 4th quadrant this time, and let's see what angles are involved here. All right, once again, if I rotate, let's just think about this. If I rotate 300 degrees, okay, counterclockwise, what angle is left right there? Well, that ends up having to be 60 degrees. That's got to be 60, okay, because all the way around is 360. All right, so that's going to make that angle here 30. All right, and so now across from 60 is root 3, but we have to make it negative because we went down. Across from 30 is 1, and the hypotenuse is always 2. And so what are they asking us for? Tangent. So tangent is opposite over adjacent. So opposite is going to be negative root 3, and adjacent is 1. So there's your answer for letter B. All right, letter C. Now, letter C, notice that the angle that it gave us is negative. We don't want to deal with that. Okay, that's a negative angle. So immediately, we are going to convert that into a positive angle by adding 2 pi. Right? By adding 2 pi, coterminal angle. So when you add 2 pi, it means you have to get a common denominator because you're adding fractions. So you need to get a common denominator, right? So that's going to be 8 pi minus 3 pi, which is 5 pi over 4. 5 pi over 4. This is such a good exercise for you guys. So now let's see if we can convert that to an angle in degrees. So 5 times 180 over 4. All right, 180 over 4 is simply 45. So 5 times 45 is 225. And after a while, you will start to memorize where these angles are. So 225. Let's go ahead and make that in the 3rd quadrant. 225. All right, so you can see that it's ending in a 5. So I'll just give you a little hint there. When it ends in a 5, that means it's going to be a 45, 45, 90 triangle. So 45 and 45 and 90. So what are the sides of the 45? Please don't forget you are going left and down here. So you need to make that a -1. You need to make that a -1. And the hypotenuse is never negative. That's going to be root 2. So remember, we're going left and we're going down. So you need to make them negative. All right, and what is it asking us for letter C? Secant. Oh, man. So secant is the flip of the cosine. So cosine is ca, adjacent over hypotenuse. So secant is going to be hypotenuse over adjacent. So your hypotenuse is going to be root 2. And the adjacent is going to be -1. And let's just review here. This is your adjacent side. That is your hypotenuse right there. So you're going to get an answer of -√2. And that is the answer. All right, let's do these last 3 examples in this section here, D, E, and F. All right, once again, negative angle, negative 270. That bothers me. I don't like that. So we're going to make it into a positive angle by understanding that coterminal angles can be generated by adding or subtracting 360. In this case, I'm going to add 360 and I get 90. So what did we just learn? Oh, negative 270 is the same as positive 90. So 90, all right? That is right there. So let's just understand something. There's 4 very special angles on the unit circle. There is 0 degrees, there's 90, there's 180, and there's 270. These have coordinates of 1, 0, 0, 1, negative 1, 0, and 0, negative 1. And we're assuming that that's the origin 0, 0. Now, the sine is going to be your y value. I'm getting ahead of myself because we're going to learn this later on. And the cosine is your x value. All right, so what is the sine of 90? It is going to be 1. I'm circling it. That's the y value. So the sine of 90 is simply 1. There's your answer. All right, tangent of 3 pi. Now, make sure you understand that the unit circle goes from 0 to 2 pi. Anything outside of that range, you need to add or subtract to get it into that range. So tangent of 3 pi, we're going to take 3 pi and we're going to subtract 2 pi from it because it is outside of the range and we end up getting pi. Now let's not get confused. The reason why we're subtracting 2 pi is because we learned in the very first slide that if you add 2 pi or subtract 2 pi, it's the same angle. So what are we really after? The tangent of pi. All right? Tangent of pi. All right, so let's draw pi. Pi is 180 degrees, so that is just going to be that angle right there. And what are the coordinates of that? Negative 1, 0. And what is the tangent? Well, you can't really draw a triangle here, can you? So you have to know that the tangent is equal to the sine over cosine. All of this we'll learn later. Or y over x. So what is the y value? 0. What is the x value? Negative 1. 0 divided by anything is 0. So that is the answer to part E. All right, last example, part F. Secant of 11 pi over 2. Okay, we're running out of space here. Let's see if we can do all of this in this little space right here. All right, 11 pi over 2. I don't like that angle. That's too big. So we're going to take that and we're going to cut it down. So 11 pi over 2, we're going to subtract 2 pi. 2 pi is the same as 8 pi. Actually, it's the same as 4 pi over 2, so let me get rid of that. It's the same as 4 pi over 2 after I get a common denominator. And what do I get? I get 7 pi over 2. Hey, that's still too big. I'm going to subtract another 2 pi, which is subtracting 4 pi over 2. 3 pi over 2. All right, let's see what that angle is. 3 times 180 over 2. 180 over 2 is 90. 90 times 3 is 270. All right, so that is the angle that we're interested in. So let's go ahead and draw that. That is going to be south. 270 is south right there. And what are the coordinates? 0, negative 1. So what is the secant? The secant is the reciprocal of the cosine. It is 1 over the cosine. So 1 over the x value of 0. We can't divide by 0. That's a mathematical rule. So that is undefined. Anytime you divide by 0, it's undefined. And that is the answer to part F. Alright, last example, because we're not going to do example 6. So, we're going to do these. Now, these can be very confusing. So, I expect some questions on these, and we're going to do as many examples as we need in class in order to make sure you understand it. Let's just go ahead and jump right in. It says that we want to find the cosine and the tangent of theta by using the given information to construct a reference triangle. Alright, what is it telling us? First and foremost, it's telling us that for letter A, that the sine of some angle theta, we don't know what that angle is, we don't care what that angle is, but that angle has a sine of 3/7. And it also tells, well, let's just start with that. So the sine is 3/7. That means the opposite over the hypotenuse is 3/7. Now once again, the sine is the y value, and it is positive. So what quadrants have a positive y value? So let's just, maybe we'll make this quadrant 1, 2, 3, 4. Alright, without much thought, you can see that quadrants 1 and 2 have positive y values. So we know from just this piece of information here, the angle theta that we're going to draw is going to be in either quadrant 1 or 2. Now, what else does it tell us? It tells us that the tangent of theta is less than 0 or negative, right? Now, that means that, once again, if the tangent is sine over cosine or y over x, how could it be negative if it's in the first quadrant? In the first quadrant, everything is positive. So it's going to be in the second quadrant, all right? Second quadrant has a positive y and a negative x because you have to go left to get there. So that means for letter A, all of that information is given to us so we know which quadrant we're going to draw this triangle in. So this triangle is going to be in quadrant 2. So we're going to draw a triangle in quadrant 2, and it says opposite is 3, hypotenuse is 7. We're going to do the Pythagorean Theorem, and we are going to get root 40 for this side, and you need to make it negative because you're going left, so please don't forget that. Alright, so that's going to be, actually let me just erase that. That's going to be root 40, negative root 40. So we want to find the cosine of theta and the tangent of theta. Cosine of theta is going to be your adjacent side over your hypotenuse. Tangent of theta is going to be opposite over your adjacent. And because it doesn't matter where the negative is going, I'm going to put it up there. And those are your answers for letter A. Okay? Letter B. Now, it's telling us that the secant is 3. Hey, they just gave us a freebie, but right now your eyes don't recognize it yet, probably. But the secant is 3 over 1. So, if the secant is the flip of the cosine, then take a wild guess what the cosine is. Cosine is simply 1/3. Alright, so cosine is the x value, and this one is positive, right? So that means you're going to the right. Alright, now go back and look at your quadrants. Which quadrants are you going to the right? 1 and 4. So this tells us that we're going to be in quadrants 1 or 4. Not sure yet, but look at what else it's telling us. It tells us that the sine of this angle theta is greater than 0 or positive. So sine is the what? The y. So that means you're going up, right? That means you're going up. So which quadrant is it going to be? Not going to be 4, so we can erase that. It's going to be quadrant 1. So you're going to draw a triangle in quadrant 1, and you're going to make the adjacent side 1 and the hypotenuse 3, because that's the cosine, adjacent over hypotenuse. When we do the Pythagorean Theorem, we get root 8 right there. Don't need to make anything negative because we're going right and up, and then we can get the tangent. So the tangent of theta is going to be opposite over adjacent. So opposite over adjacent, and that is the answer. All right, letter C, last one. Rushing through this. Cotangent is undefined, and the secant is negative. Okay, so cotangent is undefined. Well, cotangent is x over y. Remember, tangent is y over x, so cotangent is x over y. And so let's just think about this for a second. If the cotangent is undefined, then what does that mean? That means that you are dividing by 0. So that means the y value must equal 0 here. Well, let's think about these 4 special angles on our unit circle. Got them in white right there. What are the coordinates? I'm going to review. 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Okay, which angles have a 0 for the y value? It is going to be either 0 degrees or 180. All right, now we need to go to the next piece of information. What does it tell us? That the secant of theta is negative. So, which of those angles, 0 or 180, has a negative secant? Once again, secant is the flip of the cosine. So if the secant is negative, the cosine of theta will also be negative. So that's going to give us the angle of 180. So we know theta is 180. So we need to find 2 things in this problem. Cosine of theta. And that's just going to be the x-coordinate, which is going to be negative 1. Tangent of theta. Well, that's going to be y over x. What is y? Y is 0. What is x? Negative 1. Divide those and you get 0. And those are your answers to this. All right, anything else we'll go over tomorrow in class.